In this work, we propose an algorithm for the feasibility set analysis of a generic class of linear algebra problems. The proposed method is applied to the determination of the feasible Cartesian wrench polytope, associated to a musculoskeletal model of the human upper limb. To demonstrate the real-time potential of the proposed iterative convex-hull method, a collaborative carrying experiment is performed. In this experiment, a human operator and a Franka Emika Panda robot jointly carry a 7 kg object, each of them carrying a part of the total weight. The robot is modulating its assistance level to keep the relative load of the human operator at 30% of its carrying capacity. The human operator is navigating the object through the set of 4 fixed viewpoints. The evolution of the carrying capacity over the course of the experiment is shown on the upper graph in blue for the human and red for the robot. The distribution of the carried weight is shown on the graph beneath. At the beginning of the experiment, the operator carrying capacity is around 20 kg and he is carrying most of the load. However, as his arm is extended, his carrying capacity drops to around 7 kg, and in this position the robot carries most of the mass. During the course of the experiment, the carrying ratio changes several times, demonstrating the high degree of variability introduced by a human. In the second experiment, the operator changes his orientation in space with respect to the setup, while keeping the same distance from the robot and the viewpoints. The operator then follows the same cycle of viewpoints. The carrying capacity profile of the operator changes significantly from one experiment to the other. By calculating his capacity in real time, the robot is able to ensure the fixed carrying ratio in both cases. To further demonstrate the flexibility of this approach, a third experiment is conducted with less constrained operator movements. The real-time performance of the algorithm is shown on the force polytope evaluation of the human arm, with 50 muscle and a 7 degrees of freedom model. On average, the calculation takes 200 milliseconds for a defined precision of 5 newtons.